Hi folks, it's that time again. Right, so the last short was full of stuff about data and information and knowledge and wisdom, and I even talked about artificial intelligence very briefly. At the end of it, I did say that we were going to look at information technology in this short, and so we are. So let's do that. Now, if you've ever watched the IT crowd on TV, or the IT crowd if you want to be pedantic about it, you will understand that the world of IT is actually very special. It actually isn't quite as special as the TV program would have you believe, but you would be astonished at the number of times
turning it off and on again
solves a problem with a computer. Astonished, I tell you. It's amazing. You should try it sometime. Back to the real point of this little short. Information technology. You already know what technology is. I told you in the last short, stuff we make. Information technology is just technology that handles information. Simples. From our point of view, there's a couple of different things that we're going to be concerned with. One is tangible and the other is intangible. And if you think back to the first ever short that I made, I talked about tangible and intangible there. So what in information technology is tangible? Well, it's the stuff you can touch, right? Keyboards, mice, monitors, hard disk storage type things, cables, phones, cameras, you name it. That kind of stuff is what we call hardware. That's the tangible stuff. So hardware is the basic set of building blocks of information technology that allows us to do stuff. Interesting stuff, but still stuff. You've probably already thought about it, even though you might not have thought of it in this way, when, for example, you were buying, I don't know, your latest phone. Speed, storage, the refresh rate of the display, for instance. All of these things have to do with hardware. These things are all, for the most part, independent of the data that you're going to be working with and the information that you're going to be working with. I mean, sure, you can crunch numbers in a spreadsheet on your phone, but it's not that much fun. You can draw pictures on a computer screen using the mouse, but again, it's not that much fun, and the pictures that you come up with are a bit rubbish. And you could do it better with a stylus. You could do the spreadsheet crunching better with a proper computer or a laptop or whatever. What's my point here? The point is that hardware produces, when it's put together in specific ways, a set of capabilities that allow you to do specific tasks more easily. For instance, you could put together hardware that makes it easier to draw things. For example, a tablet and a stylus, if you wanted to use technology to do that kind of stuff. Personally, I use my e-reader to grade essays because whilst I can do it on a computer screen, the screen's a bit too bright for me and it makes my eyes tired, for I am very old. And the e-reader being just e-ink looks more like paper and I can just scribble on it and life is good. I use my laptop to do my video processing, although I could and I do on the road use LumaFusion on the iPad because the laptop is a bit too heavy to carry around because, like I said, I'm very old. So when you're thinking about interacting with information in some way, for example, for your business, are you interested in the visualization of the data? In which case, perhaps the monitors that you're choosing are important considerations? Or is it about the micro manipulation of massive quantities of data? In which case, possibly fast storage is something that you might be interested in more specifically. The hardware that you use should probably be dictated by the kind of tasks that you want to do. It's not that you can't do the tasks on other kinds of hardware, it just might take an awfully long time and be awfully difficult. And frankly, nobody will want to do it. And that is a problem. So what's the intangible? You guessed it. I'm sure you did. It's software. Software. Now, software is the stuff which allows you, dear human, to do things like post videos to the internet, or browse social media, or make presentations, or play games. All of these fantastic things are enabled by software that runs on top of that hardware I've just been talking about. There are a couple of different kinds of software that concern us here. The first is the operating system. Now, the operating system sits on top of the hardware and allows us to interact with it in specific ways, for example, to process data or to display data or whatever. It controls things like data storage, data transmission, networking, and so on. The basic kind of stuff that you need to do in order to build on top of it to do the more interesting things, potentially using applications. Examples of operating systems: Linux, Windows, Mac OS, iOS, Android, those kind of things. Now, I already mentioned the second kind of software, and that's applications, or undoubtedly what you call apps. And it's apps that allow you to interact directly with that information in specific contexts, to do magical things with it, even if it is just playing games. And there is serious magic happening here, even if it's just from the point of view of organizing and storing information in specific ways, which is what we might use a database management system for, and I'll talk about those in another short. Even if it's just playing games, like I said, even if it's just producing beautiful presentations or processing video. This is the magic. This is the magic part, where interacting with information and allowing humans to do beautiful things with it produces some amazing results. Here's an important thing. Consider Microsoft Word. It takes data that has been contextualized for it and allows you to produce or displays specifically formatted documents. The important word there was contextualized for it. You could look at a Word file in another application, perhaps, for instance, but what you probably get is a bunch of text that doesn't necessarily make that much sense, and even if it did, you wouldn't necessarily know which bits went where and what bits meant this is a title and what bits meant this is the body and this is the font that we're going to use, and so on and so forth. Because the data that's stored by Microsoft Word and read by Microsoft Word is for Microsoft Word to do its stuff. It speaks the language, if you like, that Word speaks. That context is important. So you see, different applications use different structures of contexts of, if you like, data stored on our various bits of hardware as just ones and zeros in order to do the jobs that they do, which allow us to interact with them and do all of the wonderful things that we do. Different applications store and process information and data in different ways, and that's where the magic happens, because it allows us as humans to do all of the wonderful things that we do with information: display it, process it, understand it, learn it, play with it, you name it, that we can do. There's the magic. One last thing before I finish this short, because I don't know how long this short has gone on, but it could be a long short. Who knows? Last short, I talked about data and that it was context free and so on, which it is. There are two specific kinds of data that we can use in the context that we've got that make it interesting. There's qualitative data and there's quantitative data. Quantitative data, strangely enough, deals with quantity, numbers, 1, 2, 9 million, whatever. It's about numbers. Qualitative data applies to the qualities of something, which can include numbers. For example, the number 3 could apply to 3 swans flying in the sky. White, black, grey, red, yellow, blue, white, etc. These things applied to specific other kinds of data are qualitative. They allow us to see the potentially useful aspects of that data from the point of view of the context that we're looking at it. So quantitative, how much? Qualitative, what's it like? Put those two things together and you get something really neat, right? And at the end of the day, applications take both qualitative and quantitative data and make it useful for us as humans and potentially as AIs, but we won't go into that right now. We might get into it later on in the course though. But we're left with a problem. Yes, we are. We are left with a problem. The problem is that we need to organize that data in some way. We need to be able to store it in a way that makes sense to us. We need to think about it, for example, in terms of student records or records of parts or human resource records or payroll data or whatever. These things, these records, these organizations, these structures are important to us when we're thinking about the processing of data and information and knowledge. And in order to do that, we need those special applications that I mentioned earlier, which are database management systems, DBMSs. And what we're going to do in the next little short is look at those. I'll see you there. It's going to be fun. Let's do it.